Welcome to today's session on rethinking the maintenance budget. Traditionally, maintenance is viewed as a cost center to be minimized, but today we're going to discuss how to reduce costs strategically. Our goal is to move from simply spending less to spending productively, ensuring that every dollar spent actively prevents future failures and optimizes lifecycle costs. I'm Santosh Raikar, and we will explore how to build a business case that executives will actually support. We begin with the budget paradox. In the world of reliability, cutting $1 from the budget does not always equal $1 saved for the company. While some cuts successfully eliminate waste, others merely transfer risk from the maintenance ledger to the production or safety ledgers. The true financial impact depends on what that dollar was doing. Was it controlling the probability of a failure or just funding an unnecessary activity? Let's look at how this plays out in real time. In the first phase of a typical budget cut, everything looks clean on paper. We remove a line item, say a 5% reduction, and the EBITDA immediately looks better. No equipment fails on the day the cut is made, creating a false sense of security that the reduction was purely waste removal. But wait until the second phase. While the balance sheet looks good, a hidden backlog is growing. The defect that would have been fixed is still there, aging in silence. As time passes, the equipment's condition worsens and your options for recovery begin to narrow, even though you can't see it in the monthly financial reports yet. Eventually, the failure sends the invoice. This is the third phase where the plant pays the price, usually at a much higher rate than the original maintenance cost. We're talking about lost production, quality issues, emergency overtime, and a massive drain on management attention. This is why a cheap budget can become the most expensive way to run a plant. So, what is our operating principle? It's simple. Cut waste, protect function, and expose risk. Cost reduction is healthy and sustainable only when it reduces the total lifecycle exposure. A defensible budget is one that removes work that adds no value while preserving critical controls, ensuring that every time we choose to defer a task, a named decision maker is aware of the risk. To manage costs effectively, we must look at the four ledgers of maintenance. Most budget reviews only focus on the first one, direct spend on labor and materials. However, to see the total cost, we must include production losses, secondary costs like energy and quality, and the broader risk exposure to safety and compliance. Ignoring the other three ledgers is like looking at an iceberg and only considering the tip. Data supports this perspective. A NIST study on U.S. discrete manufacturing found that preventable maintenance losses were more than double the direct maintenance spend. This means that for every dollar we spend on maintenance, there are $2 of potential savings hidden in the losses caused by poor reliability. The real gold mine isn't in cutting the budget, it's in eliminating the preventable losses. To find those savings, we need to distinguish between productive and wasteful spending. Productive spending is an investment that changes the condition, probability, or consequence of a failure. Wasteful spending consumes resources without changing a business outcome. When evaluating a task, ask yourself, what specific function are we protecting, and what decision would change if we didn't do this work? There are 6 primary ways maintenance creates value. Every activity you fund should fit into one of these: assuring safety barriers, preserving basic equipment condition, detecting degradation early, eliminating repeat failures, reducing repair time through better planning, or extending the useful life of an asset. If it doesn't do one of these, it's a candidate for a cut. Conversely, waste often hides in plain sight. We see it in calendar-based work that doesn't match how equipment actually fails, or inspections that gather data, which no one ever uses to make a decision. We also see waste in emergency freight costs caused by poor planning or in spending high-value resources on low-criticality assets, while high-risk defects are left to age in the backlog. Before we start chasing savings, we must protect our barriers. Mechanical integrity is not a discretionary program. For critical processes, our procedures, inspections, and timely corrections are the control system that prevents catastrophic events. These are non-negotiable items that must be funded to maintain our license to operate. Criticality is the compass that tells us where our dollars should go. It's based on three factors: consequence, what happens if it breaks; likelihood, how likely is it to break soon; and recoverability, how quickly can we fix it. By understanding these, we ensure our budget is focused on the risks that truly matter to the business. Once we know the criticality, we must match the task to the failure mode. For example, if a failure is random, time-based replacement is a waste. We should use condition-based monitoring instead. If a failure is caused by human error, we don't need more maintenance. We need better procedures or training. Matching the how to the why is the key to efficiency. It's a hard truth, but more maintenance does not always equal more reliability. Preventive maintenance, PM, can actually be a form of waste if it doesn't target a credible failure mode or if the interval is arbitrary. We should challenge any task that is more intrusive than the risk is trying to remove. In fact, maintenance can sometimes create failure. This infant mortality or maintenance-induced failure occurs through incorrect reassembly, wrong parts, or even leaving tools behind. Every time we open a machine, we introduce risk. Therefore, every intrusive task must earn its place in our strategy by proving it removes more risk than it creates. In our second section, we'll look at how to design the budget around value. The goal is to protect the core control system first, then systematically remove the sources of recurrence, delay, and unnecessary intrusion. A mature budget architecture consists of 5 protected pools. Instead of one big bucket of money, we separate spending into integrity assurance, basic condition like lubrication, risk-selected work, defect elimination, and enablement like planning and skills. This structure makes it clear exactly what we are buying with our maintenance dollars. When it comes to labor, we should optimize for capability rather than just headcount. The goal is completed risk reduction. We should protect our internal experts for critical assets, use contractors for peak loads, and focus on removing waste in the workday, like waiting for permits or searching for parts, rather than just cutting people. Spares are another critical area. They protect continuity, but they carry a cost. We shouldn't just look at inventory turns. We need to classify spares by the consequence of not having them. A $10 bearing that stops a $10,000 per hour line is a critical spare, regardless of how often it turns. Work planning is the engine that converts labor into value. A planner's budget is an investment in no surprises. By defining scope, preparing parts, and sequencing operations, planning ensures that when a technician goes to the field, the job is done quickly and correctly the first time. It is one of the most effective ways to reduce maintenance costs. For major outages, savings require readiness. The biggest waste in outages is cutting the scope after the contractors have already arrived on site. Real savings come from a rigorous freeze process, deciding what is in and what is out months in advance based on a technical risk review. In the digital age, we must remember that we aren't buying sensors, we are buying decisions. A digital investment is only worth it if the alert arrives with enough lead time for a named owner to take an action that is cheaper than the failure. Without a clear action path, expensive telemetry is just more data waste. Here are 12 low-risk moves to take cost out of your budget today. These range from deleting PMs with no failure mode to consolidating overlapping service contracts. The common thread here is that none of these actions compromise safety or critical reliability. They focus on removing inefficiency and duplication. Conversely, there are things that should never face a blanket percentage cut. Controls for catastrophic consequences need a conscious decision, not a math-based reduction. Protecting your integrity programs and your planning capacity is essential to ensuring that your cost-cutting doesn't lead to a future disaster. Section 3 addresses a critical concept: deferred maintenance. It's important to see deferred maintenance for what it really is: borrowed risk. If we decide not to do a task, we are essentially taking a loan that must be paid back later, often with high interest in the form of increased failure probability. Not all backlog is the same. We must distinguish between work that isn't due yet, work that is ready to be scheduled, work that is simply overdue, and work that we have deferred by a deliberate decision. True deferred maintenance is an intentional postponement of necessary work. and it needs to be managed as a risk. We should treat our backlog like a risk register. Instead of just looking at the oldest work orders, prioritize tasks by their consequence and the time left to intervene. Anything in the red zone needs an owner, a target date for completion, and a formal path for funding. This keeps the risk visible to the leadership team. A key tool here is the PF window. Condition monitoring gives us information, but that information only has value if it gives us time to act. If we detect a potential failure, P, but wait until it's too close to functional failure, F, to intervene, we've lost our window of opportunity and our ability to save money. When you decide to defer, you have 5 logical choices. You can accept the risk if the consequence is low, monitor it more closely, time box it for the next outage, escalate for immediate funding if the risk is too high, or prohibit operation if a critical safety barrier is at risk. A deferral is only valid if it's one of these active decisions. To make these decisions clear for management, put a dollar range on the exposure. Calculate the expected loss by multiplying the likelihood of failure by the total consequence. Use a range, low, most likely, and high, to reflect uncertainty. This moves the conversation from technical jargon to business risk. Remember that deferral compounds like interest, as we delay maintenance, the repair cost index, the risk exposure index, and the loss of recovery options all trend upward. What might be an $18,000 repair today could easily become a $750,000 failure if we wait too long. The cost of doing nothing is rarely zero. Let's apply this logic to a scenario. Should we repair a process pump for $18,000? If there's an 18% chance of a failure that would cost the company $750,000, our risk-adjusted exposure is $135,000. Spending $18,000 to avoid a large portion of that $135,000 exposure is a very sound business decision. This is how you fund maintenance. Now, consider a standby pump. If the condition is stable, the auto start is proven, and we have a spare ready, a time box deferral might be perfectly rational. The key is that the deferral is only valid while the evidence and the backup controls remain healthy. We aren't ignoring the pump. We are managing the deferral. However, some scenarios are non-negotiable. If a finding involves a pressure boundary or a safety relief path, cost does not override the safety requirement. In these cases, we must apply formal compensating controls or shut down until the barrier is restored. Integrity is the foundation of our business. In our final section, we discuss lifecycle cost as the ultimate decision frame. A great business case doesn't just look at the maintenance budget for this month. It compares complete cash flows and risks over the entire life of the asset. The purchase price is just the first cash flow. To see the true picture, we must add operation and maintenance costs, energy consumption, downtime risk, and eventual disposal costs. By discounting these back to a present value, we can compare different options on an even playing field. Often, a cheaper asset is actually more expensive in the long run. In this 10-year comparison, a low-bid option saves money up front on acquisition, but costs significantly more in maintenance, energy, and downtime. The reliability option has a higher initial price tag, but results in a $290,000 lower total lifecycle cost. To get management approval, you need a structured case. It should cover the evidence of change, the specific failure mode, the financial and safety consequences, the options available, the economics, including sensitivity, and a clear recommendation with an owner and a deadline. Your communication should be concise. A single page should make the decision clear to an executive. State the why now, the exposure in dollars, and the options. By showing that you have interim controls in place while waiting for an outage, you build the trust needed to get your budget approved. Finally, govern your budget at 3 speeds. Review condition changes weekly, spend variances monthly, and reallocate budget or refresh lifecycle cases quarterly. For the first 90 days, focus on baseline exposure and risk scoring your top items to establish a cadence for risk acceptance. I'll leave you with 5 commitments. Stop measuring maintenance only by spend. Fund safety barriers first. Remove waste using failure mode logic. Make deferrals explicit and owned, and always bring management a clear business case. The goal isn't a smaller budget, it's a lower cost, lower risk operation. To continue your journey, I provided a list of authoritative resources from NIST, the Department of Energy, NASA, and OSHA. These guides offer deep dives into everything from lifecycle costing to reliability-centered maintenance, and I highly recommend them for your technical library. Lastly, for transparency, all external data and visual credits are documented here. The scenarios we discussed are illustrative, but the principles are grounded in industry best practices and standards. Thank you for your time, and let's work toward building more resilient, cost-effective operations.